Hello and welcome. In this lecture, we're going to be dealing damage to this actor here. We're going to do that by overriding a virtual method called TakeDamage on the actor. And you can see in the log here, we've got the health decreasing as I shoot this character all the way down to 0, and then it stops at 0, not going into negative numbers. So let's dive in and see how that's done. So while we are currently being able to do damage to the actors that we hit here, such as this guy, we are not actually receiving that damage. So this is where virtual methods of the last lecture come in, because just like begin play or tick, we want to be able to receive damage on an actor. Now, fortunately, if you go to the actor.h and have a little look in here, you can see that there is this take damage virtual method. Now, this can be done also with events, and you will possibly have seen it done that way before, where you register for events. Now, what I'm going to do is just a different way of doing damage, where we actually have damage stored against the actor rather than in a component. And one easy way of receiving that damage is through a virtual method here. And this is the virtual method that we're going to override. So I'm going to go ahead and copy this and go over to our particular actor, which is the shooter character. It's going to be quicker to just go and search for the shooter character.h. And the one thing that I wanted to check is where this comes in the actor.h. So if we scroll up, we should be able to see which section we are in here. So I'm just going to scroll right up until I find that whether we're in public or what. There you go, we're in the public section, so this ought to be in the public section here as well. So I'm just going to stick it underneath our tick and setup player input component over in the shooter.h, and we just paste it in. And as I said in the last lecture, you can use override to make sure that you're indeed overriding a virtual method from the parent, and it's not necessary to have virtual in front here, but we'll keep it anyway. And here you can see all of the data that's coming in to take damage. We have got a damage amount, the damage event, and the controller that is causing the damage, the instigator and the damage causer. All that stuff that we'd passed in from the gun is cropping up here as well, so that's great. Now, if we go ahead and do a Control-Shift-P, create implementation, or copy and paste, then we can go and make the implementation for take damage. But the first thing to be wary of is that whenever we're overriding something, we want to think about calling the parent class version of take damage, because there may be some implementation in there that needs to run. So that's what we're going to do. We do this always. We've done it with tick. We've done it with begin play. You can see we've always got this super call at the beginning. And that's because when we override a method, we override it completely. We completely remove that behavior. So if we do want that behavior, which we typically do, then we should always start with a call to super. So we're going to do a call take damage. That's going to take the damage amount. So this is where it gets a little bit tedious. Sadly, my autocomplete tool doesn't do this for us. Damage event. Then what was the next one? We had the control. So the event instigator, let's just copy. And then we've got the damage causer, which is the actor. So all of that gets called up to the parent implementation of take damage. And the one other thing is that this has a return type. So the actual damage applied, so we're going to do float damage applied is the return value from take damage. So we're just going to keep hold of that damage applied there. And realistically, that's going to be the same as the damage amount in our particular use case, but not necessarily. So we're going to use the damage applied. The next thing we want to do is keep hold of the information about how much health we've actually got. Now, the way I'm going to do this is with two variables here. The first one is, I'm going to make both of them uProperties because I want to make the health visible in the inspector, at least for now. And we're going to have the first uProperty be the max health. That's what we initialize the health to initially. So uProperty. It's going to be an edit defaults only because it's going to be used in begin play, and so changing that value of max health after the effect is not going to have any impact. So max health, I'm going to set the max health to 100 here, And then we're going to have one other property here, which, as I said, is going to be a U property just for us to be able to inspect it. And I'm going to have that as visible anywhere, but not editable because we don't want to be able to change that health, at least not at the moment. You might want that for debugging purposes, but I don't. So we're going to have health here, and in begin play, we're going to set it up so that that health is equal to the max health. So we start off, we spawn, we have our maximum health, and then we can start decreasing it. So it's time for a challenge for you to decrease the health of the character. So you're going to use the damage applied here rather than the other option here. So we've got shooter character.cpp take damage. We've got a damage amount, but we actually want the damage applied that comes back from take damage because that could have been reduced by some process in the parent. So we do that, then we reduce the value of health and log the results just for simplicity's sake so that you can check that when you're shooting at that AI that his health is going down. And then test it out. So pause the video and have a go. Okay, welcome back. So let's give it a shot. So health, we basically want to decrease that by the damage applied. But is that enough? Well, what if our damage applied is greater than the amount of health we have got left? Well, in that case, we probably want the damage applied to be that amount of health. So the way we can do this is we can say that the damage applied should be equal to the fmath.min of the health and the damage applied. So this is the damage that we basically want to apply. So we're going to, I'm actually going to go ahead and rename that. Instead of calling it damage applied, I'm going to call it the damage to apply. Damage to apply, like so. Go and rename that throughout here. And then the damage to apply, we're going to health minus the damage to apply. That makes sense. And basically, at worst, that's going to be the health. So that's going to set our health down to 0. And remember, we're supposed to return the damage that we actually applied. So we'll do a return damage to apply, which has now been applied. And we finally want a UE log at the end here, which is just going to be a warning so we can see it. And I want this to be the health left here, and that's going to be a %f to, or %f to show a float. And then we can pop in the health right there and go ahead and hit build. Now mine's compiled after fixing a missing semicolon here. Let's go and make sure that we have a window, developer tools, and we want the output log here so that we can see that log message. And I'm going to go ahead and hit play and go and try and shoot at this character. If I shoot him, there you go, health left, 90, 70, 60, blah, 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 all the way down to 0. And if I keep shooting, we don't go below 0 because of that fmath.min. So that tells me that we've got our health set up correctly. Just another way of doing it, as opposed to doing it within a component, you can do it within the actor as well. There's some pros and cons of that approach. Eventually, you may want to strip this out into a separate component so that you can reuse it on different elements. But this is just another way, as I say. Now, because this character isn't looking particularly dead after we've shot him down to 0 health, we need to fix up the animations to support that. So we'll see that in the next lecture, and I'll see you there.